On the bench I have a new kit from MiniKits in South Australia. This kit is described as a driver amplifier kit. Comes in two variations. It can be used for a receiver preamp or as a transmitter chain amplifier, and the layout's a little bit different from either version, but essentially uses most of the same components. So the amplifier has no bandpass filtering. It is a broadband amplifier suitable from about 500 kilohertz through to 2 gigahertz. And so my intended use for this is with my NanoVNA. I want to amplify the output for some antenna range testing. It's a bit of an idea I've got. Whether I need this preamp or not, I'm not 100% sure, but I'm going to build it up with the likelihood that I do. So yeah, it's a kit with probably a little over a dozen components. They will be laid out on this generic circuit board that MiniKits uses for quite a few of their kits. And it is mostly surface mount components, so I'm going to use this again to develop my surface mount construction techniques. So we've got the USB microscope and the hot air rework station and the general purpose soldering iron. So well, we use all of these and try out a few different techniques. So yeah, that's the kit, and so we'll get started and push on into it. Okay, the first components I'm going to install are these two 0 ohm resistors. So this is in lieu of having a attenuator pad, so we're going for no attenuator. We can change this and go for the other variant. But initially we're starting off with these 0 ohm surface mount resistors. So just carefully remove these from the packaging, and because if you drop them they are gone forever. A tiny plastic film, just peel back, and we only need two of these. There is a spare, which is clearly for if you drop it. So my initial technique here is to put a little flux there, and do these two. Okay, this technique is we just put a bit of solder on the tip of the iron, stabilize and then let the flux draw solder in. Okay, this is a quick inspection of the PCB board assembly. The board has been cleaned with a flux cleaning solution. There should be no residue flux, which also helps with the inspection of the solder work. The amplifier has been installed in this nice aluminium enclosure. So we've connected the coax directly to the board, the SMA connectors for the input and output. The 12 volt supply is my standard Anderson connector. Got a LED indicator light, powered up state, and that's the assembly complete. Got the lid there with the basic specifications of the amplifier. So the next thing to do is to move on to testing. The test that we're all interested in is the amplifier gain, and so we'll do that next. On the bench I have the test set up to evaluate the driver amplifier. So this is a broadband amplifier. We're going to measure from 50 megahertz through to 800 megahertz, and we're measuring for gain. So we're using a NanoVNA. The output from port 1 will be fed into the input of the amplifier. The output from the amplifier we fed through this 30 dB attenuator, and then into port 2 to measure the results. Now the 30 dB attenuator is in there so that we don't overload anything and we'll get meaningful results. Also, there's potentially reasonable power coming out of the driver amplifier, and I don't want to damage the NanoVNA. So for the calibration, we're just going to take the device under test out of the system and link this straight through. And then we'll calibrate, and it'll calibrate all the characteristics of these leads, the attenuator out, and we'll have a flat 0 dB response. Okay, we'll just switch on, run through the calibration procedure. This is critical that this happens with almost every measurement with the NanoVNA. Reset, calibrate, through, done. Save in the 50 meg to 800 meg group, and we see that across we get roughly 0 dB. Oops. Out of that, go to display, scale, make it about 3 dB per increment. We can see 3 dB, I'm still reading 0. Take the link out. And we can see now we've got minus 50 odd dB. Connecting the port 1 to the input of the amplifier and the output of the amplifier via the attenuator. So unpowered, we're still showing about minus 20 dB. Powered up. Well, there we go. We've got plus 23 dB of gain at 800 megs, or 792. Down across it, so we pick up a bit more gain as we go down. The area of interest is around about 437 megs. So we're getting a pretty respectable 24 dB of gain. Increases down as we go down the band. So we have a maximum around 110 megs of 25 dB. But yeah, that seems pretty consistent. I'll just zoom in on the area of interest. We'll go start 400 megahertz, stop 500 megahertz. Yeah. All looks remarkably good. Alright, quite happy with that. It's a good test, showing the amplifier is performing well.